All right, so here is the homework for solving polynomial equations day 2. The first one says to complete this sentence. It says, if a polynomial function f has integer coefficients, then every rational solution of f of x equals 0 has the form p divided by q, where p is a factor of the constant term. So this is directly out of your notes. And q is a factor of the leading coefficient. Okay. Now, for number 2, it says, according to the rational root theorem, which is not a possible solution of the equation 2x to the fourth minus 5x cubed plus 10x squared minus 9. All right, so we're going to go through that process. So in step 1, we would identify the constant term, which is going to be -9. So I'm just going to worry about 9. And then the factors of 9 are 1 goes into 9, 3 goes into 9, and 3 times 3 is itself, so I can't use that, but 1 times 9. So those are my factors for 9. Now for my leading coefficient, I have 2. And the factors of that are going to be 1 and 2. So if I divide 1, 3, and 9 by 1, I get plus or minus 1, plus or minus 3, plus or minus 9. If I divide them by 2, I get plus or minus 1/2, plus or minus 3/2, and plus or minus 9/2. Now from here it says which is not a possible solution. So -9 is right here, -9. -1/2 is right here, -1/2. 5/2 I don't see, but let's just verify. +3 we do have. So my answer that's not a solution is going to be the letter C. That one is not a solution. All right, let's take a look at number 3. It says describe the error in factoring this polynomial. Okay. So all he's done so far is just listed the possible rational zeros. So let's go ahead and do that ourselves. So this would have been step 1. We're going to identify the constant term, which is -45. So I'm just going to write 45. And my leading coefficient is just a 1 because that's what's in front. Now the factors of 45, 1 goes into there, 3, 5 times 9 is 45, 3 times 15, and 1 times 45. So far it's looking good. The leading coefficient is just 1. Now the one mistake the person did make is when they divide each one by 1, it should be plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 9, plus or minus 15, plus or minus 45. So he only got half of the possible rational zeros when he forgot the negative parts. So this was the correct thing he should have done, or this person should have done, and that's what the error was. Okay. All right, let's move on to numbers 4 and 5. It says find all real solutions of the equation. So once again, there's 4 terms. My first thing is to do factor by grouping, but I'll just show you really quickly. If you put these two together, you can factor out an x squared, which leaves me with x plus 1. But the second one doesn't even have any common factors, so there's no way that factor by grouping will work with this. Okay. So what we're going to do now is we are going to do the rational root theorem. So hopefully you have your notes available, and I'll go through this with you. So step 1 is to list all possible solutions. Okay, so we're going to find the constant term first. In this case, it's 15. And the factors of 15, 1 goes into 15, 2 does not, 3 does, 4 does not, 5 does. 3 times 5 is 15, so obviously the last one would be 15. So these are my possible those are my factors of 15. Now we're going to find the factors of the leading coefficient. In this case, just a 1. So all of them divided by 1 are themselves. Just don't forget the plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. Step 2 is we're going to test to see which one gives us a remainder of 0. Now at this point here, I'm trying to make this process quick. So what I'm going to do here is I'm just going to use desmos to help me speed up the process. Not to give me the answers per se, but to speed up the process for me in solving this. So I have x to the third plus x squared minus 17x plus 15. All right, and I can see I have a 1, 0. So I'm going to test the point 1, 0. I know it's going to work, but it's to speed up the process, nothing else, not to give me answers. Because without the work, there will be no credit received. So coefficients, so 3, 2, 1 constant, so I have a 1 and a 1. I have negative 17 and 15. So now I have my coefficients. Now I'm just going to go through the process of synthetic division. So we drop the 1. 1 times 1 is 1. 1 plus 1 is 2. Pivot point, 1 times 2 is 2. Place it under the number. Negative 17 plus 2 is negative 15. 1 times negative 15 is negative 15. 15 minus 15 is 0. All right, step 3. We're going to write this as a polynomial. So that's going to be, if this is x cubed, then this will be x squared plus 2x minus 15 is equal to 0. Step 4, we're going to solve it. So I'm going to do the x method. 2 on the top, dividing by a, which is 1, and then 1 times negative 15 is negative 15. My factors are going to be 5 times 3, and the 3 will be minus. So here we're going to get, we get x plus 5 times x minus 3 is equal to 0. Now when I solve these, I set each one equal to 0. So x equals to negative 5, x equals to 3. So I'm going to write my solutions right here. X equals, once again, you cannot forget, this is a solution. Cannot forget that original one. So numerical order for me, negative 5 comes first, 1 comes second, and 3 comes third. Now, to verify, I'm just going to check my answers now in Desmos because I've already typed it in. Let's just verify that I got the right answers. So I have negative 5, 1, and 3, which check out to be correct, okay? So I'm using that as a tool to check my work, but also to speed up the process a little bit. So hopefully you understand that's what I'm doing. All right, let's take a look at number 5 now. So for number 5, same thing. You can try factor by grouping. It's not going to work, unfortunately. So let's go through the process again. Step 1, we're going to list all possible solutions. So we're going to find the constant, which is 30. And the factors of 30, so 1 goes into 30, 2 goes into 30, 3 goes into 30, 4 does not, 5 does. And then 5 times 6 is 30, 3 times 10, 2 times 15, and 1 times 30. So you can see this one has quite a few. For my leading coefficient, once again, it's a 1, so that does make it nice. So if we divide every single one by 1, it's itself. Once again, do not forget the plus or minus when you're listing out your possible solutions. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 5, plus or minus 6, plus or minus 10, plus or minus 15, plus or minus 30. All right, on to step 2. So we're going to test the point. Once again, that's a lot of solutions. That's 2, 4, 6, 8, 10, 12, 14, 16 of them. So once again, I'm going to type this into Desmos so that I can find that one I need to test pretty quickly here. Now, let's say you get to your next math class and you're not allowed to use a calculator to do this. Then you're going to have to test these points individually. But you know the process is the same. It just could take a little bit longer considering you have to start testing points. So once again, I always start by, just like if I was doing this regular, I would do positive 1, then negative 1, positive 2, then negative 2. I'd work it through until I could find it. As you do this more, you do become proficient, and you start to see a couple of patterns here. So right now, show you the graph I have, and I'm going to start with negative 1 because that's the first one that came up. So when we test negative 1, the remainder should be 0, but we still have to show the work for this process. So x cubed, negative 10x squared, 19x, and 30. So far we've had no zeros because we've had no missing variables or powers. So go through the process, drop the 1. Negative 1 times 1 is negative 1. Combine. Negative 10 minus 1 is negative 11. Negative 1 times negative 11 is positive 11. 19 plus 11 is 30. Negative 1 times 30 is negative 30. And guess what? My remainder is 0. Once again, at the very end, this is a solution. Do not forget that. Okay, step 3. Write it as a polynomial. So if this is x to the third, then this will be x squared minus 11x plus 30 is equal to 0. Step 4, we're going to solve it. So let's go do the x method here. B is negative 11, dividing by a, which is 1, and then 1 times 30 is 30. So my factors are 5 and 6, and to make it negative 11, it's going to be negative 5 and negative 6. So we have x minus 5 times x minus 6 is equal to 0. Set each one equal to 0. X equals 5, x equals 6. So when I write my final solutions, like for me, like I said, I like to put them in numerical order, so -1, 5, and 6. Okay, and once again, I'm going to check my answers in Desmos, right? I've done all the work. Now I'm just checking to make sure I'm good. So we have -1, 0, 5, 0, and 6, 0. Okay. All right, let's keep moving on. So these ones here, you can see, are going to be the ones that are when a is not equal to 1. So step 1, let's identify our constant, which is going to be -24, so I'm just going to write 24. So the factors are going to be 1, 2, 3, 4, 6, 8, 12, and 24. My leading coefficient is going to be 2, so the factors are 1 and 2. So if I divide all these by 1, they're the same number, so plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. Now I'm going to divide them by 2. So 1 divided by 2 is 1/2. That doesn't repeat. 2 divided by 2 is 1, so I don't need it. 3 divided by 2 is 3/2. 4 divided by 2 is 2. 6 divided by 2 is 3. 8 divided by 2 is 4, so you can see those are all there. 12 divided by 2 is 6. 24 divided by 2 is 12, and they're all there. So those are my factors. I'm pretty sure this one is probably the same one that we just did in the notes. Or at least it looks similar to it. I could be wrong. Okay, so anyways, let me just keep going here. So once again, now with this type of problem, I'm going to test it in Desmos. Okay. So let's go ahead and pull this up here. So let's type this equation in. Once again, this is to speed up the process so I can find the delete that there. There we go. So 2x cubed minus 3x squared. So this is to speed up my process, not to give me answers, even though it's giving me one of them, right? Okay, so there we have that there. We see -4. So let's go ahead and use -4 as our point to test. So -4. So we have x cubed, x squared, x constant. So 2, -3 are my coefficients. -50 and -24. So process, drop the 2, multiply it to the pivot. -4 times 2 is -8. -3 minus 8 is -11. -4 times -11 is 44. -50 plus 44 is -6. -4 times -6 is 24. And guess what? The remainder is 0. So don't forget, again, this is your solution. You cannot forget that. All right, for step 3, we're going to write it as a polynomial. So x cubed, this becomes 2x squared minus 11x minus 6, set that equal to 0. Step 4, we are going to factor this since it is a quadratic. Now, if it wasn't factorable, obviously, or hopefully you see, I would have to do like the quadratic formula. 2 times -6 is -12, and that would be -12 and +1. So -12 plus 1 is -11. -12 times 1 is -12. This can reduce to -6. So we do have x minus 6, 2x plus 1, set that equal to 0. Set each factor equal to 0 now. So this one is x equals 6 and x equals -1/2 because I have worked these out before. So once again, I tell you I like to put them in numerical order, and I just put it off here so you can see it. So -4 is my smallest number, -1/2 is next, and then we have 6. And you can verify this once again. Let's take a look. So -4, -1/2, 6. So -4, put -0.5, and 6. So my solutions do check out. Awesome. All right, let's take a look at number 7 here. So number 7, we're going to do the same process. So step 1, let's go ahead and find the constant, which is going to be -40. So I'm just going to write 40. Factors, 1 goes into there, 2, 3 does not, 4 does, 5 does, 6, no, 7, no. 5 times 8 is 40, 4 times 10 is 40, and 2 times 20, and 1 times 40. So those are my factors of the constant term. Now let's go ahead and find the factors of the leading coefficient. In this case, it's 3. Okay, so we have factors of 1 and 3. So when I write these out, if I divide all of these by 1, it's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 8, plus or minus 10, plus or minus 20, plus or minus 40. Now I'm going to divide them by 3. 1 divided by 3 is 1/3, so that one's not repeated. 2 divided by 3 is 2/3, that one's definitely not repeated. 4 divided by 3 is 4/3. 5 divided by 3, again, not repeated. So now you can see this one has quite a few. 8 divided by 3 is 8/3. 10 divided by 3 is 10/3. Let's not forget the plus or minus. 20 divided by 3 is 20/3. And then 40 divided by 3 is 40/3. And don't forget your plus or minus. So you can see this one has a lot of possible solutions. So when we go to step 2, this is probably one of the best examples of why you should be using desmos to help you test that first one just for this particular part, because it's a lot of fractions. There's a lot of possible solutions. Okay, so let's go ahead and type this in. 3x cubed minus 25x squared plus 58x and minus 40. All right, so you see right here, I'm going to just pick one of the whole numbers. So 2 should work. Let's go and take a look at that. So we're looking for that remainder of 0. So x cubed, x squared, x constant, so 3, negative 25, 58, and negative 40. All right, so from here we're going to drop this 3. 2 times 3 is 6. Negative 25 plus 6 is going to be negative 19. 2 times negative 19 is negative 38. 58 minus 38 is going to be 20. 2 times 20 is 40, and my remainder is 0. Awesome. Step 3, we're going to write as a polynomial. So this was x cubed. This will be 3x squared minus 19x plus 20. For step 4, I'm going to do the x method. So b is negative 19, a is 3, and then 3 times 2 is 60. All right, so what are my factors that add to negative 19 but multiply to 60? 15 and 4. Both will be negative. So negative 15 plus negative 4 is negative 19. Negative 15 times negative 4 is positive 60. So that works out. All right, so we can reduce this to negative 5. So then my factor is going to be x minus 5. This one cannot reduce, so 3x minus 4. Let's go ahead and set that equal to 0. Now set each factor equal to 0. So x is equal to 5, and x is equal to 4/3. And I'm just going to write my solutions here because I don't have enough room up there, I don't think. So x equals, let's see, my first one. Ooh, see, I almost forgot there. 2 is my first solution. I have a 5, and I have 4/3. So the smallest one is going to be 4/3. Then I have a 2, and then I have a 5. All right, and we're going to just verify this in desmos to make sure I am close on this. So we have 1.333, which is 4/3. We already knew we had 2, and there's my 5. Okay, so we just checked our answers. All right, last one we have is number 8 here. So number 8 says, use the information in the graph to answer the questions. So letter A says, what are the real zeros of the function f? Okay, so when I look at this here, I can see that my solutions are x equals negative 2 and x equals positive 1. So those are the zeros of the function. Now it says write an equation of the quartic function in factored form. Okay, so if you recall, linear is x to the first, quadratic is x squared, cubic is x to the third, quartic is x to the 4th power. Okay, so what we're first going to do is we're going to unsolve this. Okay, so when I say unsolve it, so let me work this out over here. So we're going to unsolve it. X equals negative 2, x equals 1. So I'm going to just, when I unsolve it, I'm going to add the 2 back to the same side as the x. And that's going to give me x plus 2. I'm going to put it in parentheses. Over here, I'm going to subtract 1. And this gives me x minus 1. Now, if you recall from behavior from the last lesson, well, since it touches and it turns, that means it's a multiplicity of 2. It's squared, it's even. Okay, and I don't know, really, it's not necessarily squared, but it's an even power. And since it's quartic, I know this must be squared and this must be squared. And now if you think about it, x squared and x squared does give you x to the fourth, and that is my quartic. Okay, so when I write this, I'm going to write, you can write y, but I'm going to write f of x equals x plus 2 squared times x minus 1 squared. And there's your answers to number 8.